Hi students, we're going to be starting our unit on graphing, and so we're going to learn how to take an equation, kind of like the equations we've just been looking at, that have one variable, and how to graph them. But now all of our equations are going to have two variables. They're going to have an x and a y. So we're going to come back to the coordinate plane. So I just want to review the coordinate plane really quickly. Make sure we're all familiar with our coordinate plane. Our coordinate plane is just a grid system. It's a grid system that allows us to find exact locations. And we use coordinate planes all the time. We just might not even be aware that we use them. Maps work on a coordinate plane with our equator and our latitude and longitude. So we really do use coordinate planes a lot. Now, when we're graphing a two-variable equation, we have the y-axis. The y-axis is this line here, right, that goes up and down vertically. That's our y-axis. And we have our x-axis. Our x-axis is our horizontal line. And these are just numbers that help us pinpoint location. And when we're looking at these axes, we label the four sections. Hopefully we can see the four sections. So this would be our first section. We call that quadrant 1. This would be our second section. We're talking about all the points that fall in this area. This would be our third section, our third quadrant, and this would be our fourth section, our fourth quadrant. And so every single location in that coordinate plane has an exact point, an exact value we can give it. So for example, if I was to make a dot right here, I can give that dot a specific name using an ordered pair. And we list those ordered pairs according to their x value, where they fall compared to the x-axis, and compared to their y value, where they fall compared to the y. So we always start with x, then y, alphabetical order. So this particular coordinate, we can see that on the green x-axis, it's right above the -3. So that means our x value would be -3. Then when we look at our y value, where does it fall compared to our y-axis? We can see that it's over here, right across from the number 1. So our ordered pair would be -3, 1. So we're going to be using our coordinate plane to graph points, and then we're going to be using it to take an equation to find points and then to graph those points. Now, the first thing that we usually do when we're looking at an equation is we determine whether an ordered pair is a solution. Whether something's a solution just means, does that ordered pair make the equation true? So what it's asking is, if you plugged that in, is it true? Does it make the equation work? Now, most equations only have one point that makes it work. And that point is where the line crosses a specific location. So we'll learn about that. So I want to know, is this ordered pair part of this line? So it sounds really complicated. So if I were to graph this, a two-variable equation that has no exponents makes a straight line. These are called linear equations. I want to know, is this point on that line? That's what would make it true. So the first strategy we're going to use is called substitution. And then we're going to learn that we can actually graph an equation without knowing values, and then we would be able to see all the points that make the line. So we'll start with substitution. All we're going to do is take this ordered pair and plug it in. So we have 5 times x, the x value is -3, plus 4 times y, the y value is 2, equals 6. So we just follow order of operations. 5 times -3 is -15. 4 times 2 is 8. Negative 15 plus 8 is negative 7. Now, this is where we decide, is this a true statement? Is negative 7 equal to 6? Well, no, of course not. So we would say, no, this ordered pair is not a solution. Now, what does that actually mean? That means if I were to take this equation right here and I were to graph it on a coordinate plane, I would have my graph on my coordinate plane, and I'm not going to graph it accurately, but it would look something like this. This would be the graph. The graph is just the line. So this pink indicates the line. Again, I haven't graphed this accurately. And then I'd be looking at the point negative 3, 2. It would be way off here. The green point does not fall on the line. That's what no solution means. It means the line and the point are totally separate. They're not, the point is not on the line. Okay? So, another thing we're going to learn that's really important about graphing is something called solving for y in terms of x. Now, we've learned how to solve a one-variable equation. Remember, we saw equations like 2x plus 6 equals 8. And we learned how to get x all by itself and solve for x. So we had x equals, and then we had a number. Well, we're going to solve for y. So we're going to get y all by itself, but we're not going to have a number over here. We're actually going to have an expression because we have two variables. So on the right-hand side, there's still going to be the variable x. On the left-hand side, there's going to be a y. So that's what this means, solve in terms of x. So my goal is to get y by itself. So the first thing I'm going to do is move the 4x. So I get rid of a positive 4x by subtracting 4x from both sides. And this is where all of those strategies of solving equations are going to continue to come up as we get ready for algebra. So we had a 4x minus 4x, those are gone. Be really careful here. Don't forget the negative in front of the 2y. So we have negative 2y equals. Now, these are not like terms, so we cannot combine them. We just write them next to each other. We always put our variable term first. So we have a negative 4x and a positive 12. Okay, we're almost there. Now we're going to get rid of that negative 2. The negative 2 is being multiplied by the y. So the opposite of multiplication is division. We're dividing by negative 2. Our negative 2's go away. Now remember, we talked about this with solving equations. We need to divide both terms by negative 2. So negative 4x divided by negative 2, and negative divided by negative is a positive. 4 divided by 2 is 2x. Positive 12 divided by negative 2 is negative 6. So this is our equation. Notice how we solved for y. Y is all by itself in terms of x. That just means the right side of the equation is going to have an x, and that's okay. So our equation is y equals 2x minus 6. We're going to learn that this is a really special form of an equation, and it's going to become one of your favorites because graphing it is going to be really, really fun. So here we go. Let's practice doing some graphing. Okay, so now we're going to learn how to graph the equation, and we're going to graph using what is referred to as a table of values. So that's what the directions will usually say in most textbooks. I personally call this strategy the H-chart strategy. So the H-chart is how we're going to organize and show our work. So I know that this line, because it has an x and it has a y, it's a linear equation. That means it's a straight line. But that also means that there's many, many, many ordered pairs that fall on that line. Now, I can't possibly find all of them. That would take forever. But I can find some of them, and then I'm able to draw the line. So what we're going to do is we're going to create our H chart. It's just a chart, like so. We're going to put our equation in the middle. Y equals 4x minus 1. And what we're going to do is we're just going to solve for ordered pairs. Now, when I'm solving, I could plug in any number for x that I want. I could plug in 12, I could plug in 5, I could plug in -4, and I'll be able to find the y that matches up, what makes its pair. But I don't want to have to draw a graph that's ginormous. So generally speaking, when I'm graphing, I like to use -1, 0, and +1. That just keeps my graph a lot smaller and manageable. So that's what we're going to practice. So the first thing I'm going to do is I'm going to plug in -1 for x. So I have y equals 4 times -1 minus 1. So y equals 4 times -1 is -4 minus 1, and -4 minus 1 is -5. So that means 1 point on this graph is -1, -5. That's just 1 point on the graph, okay? Another point on the graph, this time I'm going to plug in 0. So y equals 4 times 0 minus 1. 4 times 0 is 0, and 0 minus 1 is -1. So another point on this line is 0, -1. Okay? Now I'm going to find a third, and I'll explain when I draw my graph why I want 3 ordered pairs. 2, I could do it, but I won't catch a mistake. With 3, if I made a mistake, I will catch it. So the last value I'm going to plug in is a +1. So y equals 4 times 1 minus 1. 4 times 1 is 4, and 4 minus 1 is 3. So my last ordered pair is 1, 3. So now what we're going to do is we're going to put a coordinate plane up here, and we're going to graph these 3 points. Okay, so what I've done now is just put my graph up here, so my coordinate plane, so I can graph these points. So first point that I'm going to graph is that point -1, -5. So I'm going to go over to -1, down to -5. There's my first point. My second point that I'm going to graph is that point 0, -1. So over 0, down -1. And the third point that I'm going to graph is 1, 3. So over 1, up 3. Now, if I've done everything correctly, these points line up in a nice straight line. And if I had a ruler, that would be even better, but I don't. So there we go. Okay, and they make a nice straight line. Now, because, if I can get that a little straighter, there we go, took out my ruler. If they didn't line up, like sometimes I'll see people do their graphs and they've got a point here and a point here and a point here. That means something went wrong. So you're going to practice doing the H chart and making some graphs.